In today's video, we're going to look at section 2.3, arithmetic operations on matrices. In this section, we're just going to discuss exactly what is a matrix, and then how can we put these matrices together. So how can we add them, how can we subtract them, and then eventually we're going to look at multiplying. But first, I want to look at some fundamental things and properties of matrices, just so that we are all on the same page before we go ahead and do this. So what exactly is a matrix? We've been dealing with them in the last couple sections, but how do we define a matrix? A matrix is literally just a rectangular array of numbers. Okay. It doesn't matter how many rows you've got, how many columns you've got, as long as every single entry actually has a value in it within those rows and columns. It can be whatever size that you like, as long as it is rectangular. As I said, we can add these together, we can subtract them from one another, and we can multiply them together. And we're going to look at each of those functions. And eventually we will also look at some real world examples of where these things are used. Just as general notation, whenever we refer to the size of a matrix, it's always given in terms of row by column. So you're going to get something, when you look at the size, it's going to look like A times B. Okay, we actually call this A by B. Okay, so for example, if we have this matrix, I'm just going to make up a random matrix here. This matrix has 3 rows and 2 columns, so we call it a 3 by 2 matrix, and that's how we write it. Okay, if you had 2 rows and 3 columns, it would be a 2 by 3 matrix, so it's always the number of rows by the number of columns, so the rows always go first. So whenever you see that notation, that's what it means. If a matrix only has one row, it's called a row matrix. So a row matrix is literally just a matrix with one row. So an example of that would be something like this. Don't put commas or anything between each of the entries, especially when you've got a row matrix. It's kind of, people tend to try to do that to make it look like a pairing or something weird like that. Don't do that. Just make it, each entry is its own thing, and don't put any commas between them. But this is called a row matrix. You can have as many columns as you like. You can have one or however many. It doesn't matter, but this is a row matrix. Column matrix similarly has one column. So an example of that would be something like this. Okay, so it just has one column, however many rows. If you have a matrix that has the same number of rows and columns, then it is called a square matrix. So a square matrix has the same number of rows and columns. So an example of that would be a 3 by 3 matrix. Has 3 rows and 3 columns, same amount of rows as columns, and it could look something like this. That would be a square matrix. This is more of a notation thing. So for example, if I go back to my last matrix that I wrote out, this 3 by 3 matrix here, I'm going to write this out. I'm going to call this matrix A. General notation, whenever you refer to a matrix, you always use a capital letter. Okay, so we're going to call this capital A. It's going to be what this matrix is called. And then we also need to deal with subscripts, because let's say I am referring to this entry here. Okay, this 8. I would refer to this as A3, 2. Okay, A3, 2 is equal to 8. I use the lowercase version of whatever letter I've used to denote my matrix. And then it is the 3, 2 entry. It is in the third row and the second column. So it is the 3, 2 entry. If, for example, I was looking at this 3 here, that would be A1, 3. Okay. Again, I've used that lowercase a, and then it is in the first row and the third column. So you always do row, comma, column. Okay. If we want two matrices to be equal, so if A equals B, you've got two conditions here. Number one, the matrices have to be the same size. And number two, the corresponding entries also have to be equal. Okay, so every single entry has to be the same as the entry that is in the other matrix. So for the above matrix that we have here, B would literally have to be the exact same matrix. So the exact same size, and each entry is in the exact same position. So I have a 1 in my first position here, in my 1, 1 position. My 1, 2 position is a 2, etc. So if A equals B, number one, they have to have the same size. And the second thing is that they have to have equal corresponding entries. So they must look exactly the same. Now we're going to look at adding two matrices together. So if we add two matrices together, they have to be the same size. Why is that important? Well, we add the corresponding entries to each matrix. So when we do this, let's say our example, I'm going to do two different 3 by 2 matrices. So I've got 1, 2, 4, -1, 3, -9, plus -2, 6, 1, 1, -4, 7. So I'm adding these two matrices together. They have to be the same size because when we add matrices, we just add their corresponding entries. So my 1, 1 entry, this first entry in my resulting matrix, is just going to be this 1, 1 entry plus this 1, 1 entry. So 1 plus -2 gives me -1. Then 2 plus 6 gives me 8. 4 plus 1 gives me 5. -1 plus 1 gives me 0. 3 plus -4 gives me -1. And -9 plus 7 gives me -2. Okay. So this is how we add matrices together. You literally just add their corresponding entries. Same deal goes for if you're subtracting matrices. So when you subtract matrices, you just subtract the corresponding entries. Same deal goes for when you were adding them. You have to have matrices of the same size or this doesn't work. So if I took my last example, but this time I subtracted the two matrices, I just subtract my corresponding entries. So 1 minus -2 is going to be 1 plus 2, which is 3. 2 minus 6 gives me -4. 4 minus 1 is 3. -1 minus 1 is -2. 3 minus -4 is 7. And -9 minus 7 is -16. Okay, so it works exactly the same as adding matrices. We have to make sure that the matrices are of the same size, and then we just add or subtract the corresponding entries accordingly. The other thing that you can do is multiplying a matrix by a scalar. That means that I'm just multiplying a matrix by some constant value. Okay. So when multiplying a matrix by a scalar, you multiply every entry in that matrix by that scalar. Make sure that you do that to every entry, because people tend to just do random mathematical errors with this and miss an entry or something. So make sure, particularly in an exam situation, that you multiply every entry in that matrix by that scalar. It's exactly the same as when we were doing the Gauss-Jordan method, where we were multiplying a row by a scalar. Make sure that you would multiply every entry in that row by that scalar. Same deal goes here. You are just going to multiply every entry in the entire matrix by that scalar. So our example for multiplying a matrix by a scalar, it would look something like this. So I have 5 multiplied by this matrix, so I multiply every entry in my matrix by 5. Okay, so how do I do this on my calculator? The first thing you need to do is to go into the matrix menu. So you're going to go to second and matrix. I've already put these matrices in, but I'll show you how I did it. You go across to edit. We did this before when we looked at the reduced row echelon form for our Gauss-Jordan elimination. You go across to edit and you click on your first matrix, A. Now in our example, A was a 3 by 2 matrix. So I've just clicked 3 by 2. And then you can edit each of the entries in your matrix. Just go along, you can go up and down and side to side to change each of the entries in the matrix. Once you have done that, you actually have to come out of the matrix menu and then go back in. So you're going to go second, quit, and then you're going to come back in. So second and the matrix menu. Go across to edit, and now you can do matrix B. It's annoying that you have to come out and go back into that matrix menu, but otherwise it tries to give you a matrix inside a matrix and it gets messy. So whenever you do this, for each matrix, always go back into the matrix menu to edit a new matrix. So I've put my matrix B in exactly as it was in our example. Then you come out of there. Now in my first problem, I added the matrices, then I subtracted them, and then I multiplied by a scalar. So to do this, I go into my matrix menu and I call the matrix A. So you stay on this first menu of names and you just click A. And then I added my matrix B. So I go down to B, click enter. Okay, so this time I'm calling the matrices. I'm not editing them, I'm calling them. So stay in that names menu and just click on the matrix that you want to use. So I did A plus B. If I click enter, it gives me the exact same matrix that I got when doing this by hand. To subtract them, you do the same thing. So I go into my matrix menu, I call matrix A minus matrix B, gives me the same matrix that I had when I worked this out by hand. And finally, to multiply by a scalar, you literally do it like we wrote it. So I had 5 times my matrix A. So 5, and then I'll call my matrix A. And I get that matrix. So you can literally just do 5 and then A. You don't have to do multiply or anything, just do 5A. Okay. So whenever you do this, use that matrix menu, and remember, I know it's annoying, but you do have to come out of the matrix menu each time you want to input a new matrix.